Good afternoon, everyone. Welcome to new webinar. My name is Evan. Today, I would like to introduce you network basics for surveillance. And I will take around 20 minutes to introduce, and after 5 minutes break, we will have 10 minutes for the Q&A. To ensure the quality of the webinar, I will mute everyone from now. So if you have any questions, please type in the question window. So here is today's agenda for topic for this webinar. And after finish these 4 topics, we will have 10 minutes Q&A section at the end. Okay, the first topic is how to calculate the required bandwidth approach relativity. In a data transmission, measured in bit per second is called the bit rate. It is the measure of bandwidth. It is commonly measured in thousands of bits per second or kilobit per second. So first, we need to know which will affect the bit rate. In the IP camera settings, there has 3 camera parameters will affect the bit rate size. First is compression, and second is the resolution, and last is the frame rate. So what is the resolution? The resolution means the number of pixels on the image. For example, this image shows the width and height of image in pixels. In other words, how many pixels are in our image from the left to right, and how many pixels are in image from the top to bottom. It is also telling us one other important piece of information, which is the file size of image. For example, the 2 megapixel resolution is width of 1920 pixels and a height of 1080 pixels. In other words, it contains 1920 pixels from left to right and 1080 pixels from the top to bottom. To find out exactly how many pixels, we can simply multiply the width times and the height, which in this case is 1920 times 1080, which gives me a grand total of 2,073,600 pixels. That's all lot of pixels. So why we call the full HD resolution is 2 megapixel. The mega means million. So 2 megapixel means 2 million pixels. This means that when 2 megapixel IP camera video has made out of 2 million pixels, if you have a 5 megapixel IP camera, your video will be made out of 5 million pixels, and the higher resolution is made out by more pixels. So that will cut the file size higher and need more bandwidth to transfer the video. So the second is frame rate. The frame rate means how many frames per second, and it is also called the FPS. When a file is transferred, frames are continuously delivered from the computer transferring the video, and each frame is displayed as it is received. And the more frames per second will show the smoother video to the viewer. So a least frame rate video is very slow and the things shows like still pictures in the video. In the video system also has NTSC and the PAL system. And if they say the real time, it means the picture are 25 frames per second in PAL system and the 30 frames per second in the NTSC system. But the higher frame rate will cause the bitrate higher. So if you want to transfer real-time video, you must need more bandwidth. Due to the raw picture file size is too big, and if you want to transfer the real-time or higher frame rate videos, that will require very big bandwidth to do that. So currently, we are using video compression technology to encoding raw picture to make its file size smaller. Currently, the IP cameras, the video encoding is include motion JPEG, MPEG-4, and the H.264. And then the H.264 is a more advanced version of MPEG-4 codec. Here we see the different types of encoding is the single frame and the multi-frame. With the single frame mode, the single frame encoding, each frame of the video is encoded separately. The video is essentially created by combining a series of the complete JPEG picture files. The benefit of a motion JPEG is requires low CPU use and cleaner individual image. But the motion JPEG will need higher bandwidth requirement. Okay, next is the MPEG-4 and the H.264. Both the MPEG-4 and the H.264 are used multi-frame compression. First, a single reference frame is encoded. Then for additional frame only change with the respect to the reference frame are stored. This means much of redundant data is left out to keep the data size and the bandwidth consumption low. As we can see in the example, the image of the people and the house are stored in the first frame. Since the people is moving, the image of the people is encoded on all other frames. In the series picture at the bottom of the screen, the image of the moving people is encoded on every frame. The background as represented by the house does not change, so it is not encoded, which in turn to save the bandwidth. So now we know which will add the bitrate size. First is the video compression. The H.264 can have better video quality and the lowest bandwidth. And the second is resolution. The higher resolution will need higher bandwidth. And the last is the frame rate. So how we calculate the bandwidth for project? Okay, you may use the Nuo design tool to calculate the bandwidth requirement for your project. Here is the Nuo design tool web interface. As you can see, you can put the number of the cameras and the resolution and the params in this page and click the calculate button. Then it will help you to get the minimum bandwidth. For notice, this is only for reference because there are some internal factors. For example, different camera model may have different compression ability, although they are using the same video format H.264. Some IP camera that has better compression ability can save more bandwidth, such as H.264 high profile, but that will consume more CPU resource to do decoding. Okay, now we go to the second topic. The second topic is also the topic that many customers have asked. How many client output stream connections do NUO NVR support at the same time? First of all, in NUO main console, you can find the live stream getting setting page in the network service setting. And you may also see the MASMA connection. But what is the MASMA connection means? Okay, it means number of connections that are allowed to connect to the main console server. And the default, the MASMA connection is 128. One camera video counts as one connection. For example, a user at a remote site and install the remote live view application, and it connect to the main console server to see a 4-channel live view at the same time. One channel will consume the main console server one live view connection. So in this scenario, it will consume the main console server 4-channel live view connection. Okay, this is another scenario. There are 3 remote sites, and each remote site is installed the remote live viewer application. And these 3 remote live viewer applications are connected with the same main console server at the same time. The first remote client side is connected with the 4 channels. And the second remote side is connected with the 16 channels. And the third remote side is connected with 9 channels with the main console server. So there are 3 remote sites, and they will consume 4 plus 16 plus 9 connections. So the total connections are 29 connections. And the main console server will still can output 99 live view connection to the other client side. So how about the user at the remote site want to see the playback video from a main console server? In this, user goes to NUO main console network service setting. He or she can also find the remote playback page. And this is a big difference between the live streaming and the remote playback. The live view streaming is by connection, but in the NUO main console is by the user. So you also can see there has a MASMA user in the remote playback page, which means number of the users are allowed to connect to the system. And the default and the MASMA is a 64 user to connect to the main console server to see a playback at the same time. And please note that a user can only see 4x4 is total 16 channels in the neural playback system at the same time. Okay, for example, there are 3 remote sites, and each remote site is installed a neural playback system application. And these 3 users are using neural playback system to connect to the same main console server. As I mentioned previously, the main console server can allow the 64 user to use neural playback system to check the recorded video at the same time. So in this scenario, only are 3 users using neural playback system to check and record the videos. These 3 remote client sites will consume only 3 users, and the main console server will allow 61 users to connect to see the playback videos. Okay, this page shows neural NVR output live view connection and the playback user and the connection per server at the same time. And the main console server can output 128 live view connections and 64 users for playback. And the NVR Mini 2 can output 60-volt live view connection and 8 users for the playback at the same time. And how about the NVR Solo, Titan NVR, and the Crystal Titan NVR? Due to both of the NVR Solo and the Titan NVR support local display function, it will cause the CPU loading higher because the CPU need to do a decode. Also, the different recording throughput will cause different live view and playback output. So please note, the Crystal Titan NVR is different from Titan NVR and the NVR Solo. The output playback is calculated by the connection instead of by the users. So let's start from the NVR Solo. The NVR Solo supports local display function, and you can refer to our test scenario in the NVR Solo optimal performance guide. And in our test scenario is based on basic use case of NVR Solo, full recording, local display, and storage for auto recycle. And the camera parameters are h.264 with baseline profile and high quality and moderate traffic. For the NVR Solo 1-bay model, when NVR Solo connect with a piece of D1 or 1.3 megapixels cameras by 30 frames per second, the recording throughput reached to 60 megabits per second. The NVR Solo can output 16 live view connection and 8 playback connection for remote client. And then there's another test scenario which is connect with 8 piece 2 megapixel IP cameras at 15 frames per second, and the recording throughput reached to 60 megabits per second. In this scenario, the NVR Solo will output 16 live view connection and 8 playback connection for remote client. And in the NVR Solo 8-bay model, it can be connected with the 16 IP cameras. When NVR Solo connect with the 6 piece of the D1 or 1.3 megapixel cameras at 15 frames per second, and the recording throughput reached to 80 megabits per second. The NVR server can output 16 live view connection and 4 playback connection for the remote client. And for others test scenario, you may connect with our NVR server optical performance guide by this link. Okay, the next is Titan NVR, also support the local display function. While Titan is able to record up to 250 megabits per second of the data throughput, the scenario of the 180 megabits per second or below is recommended. The purpose of this test scenario is to help users to understand the best use case regarding individual Titan's recording performance. For Titan NVR R1 and the tower model, when it is connected with the 30 piece of D1 or 1.3 megapixel cameras at 25 frames per second and shows the full churn local display, it can output 30 live view connections and 16 playback connections for remote client. And if it is connected with the 64 1.3 megapixel IP cameras with the 8 frame rate per second, and shows the full churn local display too. In this scenario, the Titan NVR will output 128 live view connection and 16 playback connection for remote client. And then in the Titan NVR2, due to this model are using the Intel i5 CPU, so it can have better performance than Titan R1 and the Tower. So Titan NVR R2 connect with the VGA D1 and the 2 megapixel and the 5 megapixel IP cameras and shows the 16 channel in local display. The Titan NVR R2 can output 128 live view connections and 16 playback connections for remote client. And you may find this test performance guide in this Titan NVR spec sheet. Okay, for Crystal Titan NVR, we have tested the recording server and the metadata server. Our test scenario is the performance result for system with a single variant in RAID 5. The system is operating live view, playback, record, and recycle simultaneously, but not doing backup. We recommend the CT8000R, CT8000RP for recording throughput better than 180 megabits per second. In this page, the table provides the detail of the Crystal Titan optimal use case. When the Crystal Titan NVR be as recording server, for example, the CT4000 model connect with the 64 2 megapixel with 15 frames per second, and it can output 128 live view connections and 16 playback connections for remote client. Also, there are CT8000R and the CT8000RP performance test report, and we have also tested the metadata server. and the test result will show as in the list table for your reference. Okay, in this topic, I will explain the private and public IP address and the NAT functions. And then I will show you how to set up port forwarding in the router. In the network, there are two different types of IP address. One is private IP address, and the other is the public IP address. But what is the difference between the public and the private IP address? A public IP address is that one that your ISP provides to identify your local area network to the outside world. It's an IP address that is unique through the entire internet. And the private IP address is any number of addresses assigned to a device on a private network, local area network. That is accessible only within the local area network. As you can see, both of the device A and B are with the private IP address in local network. So if the remote site user need to connect to a device A, the user can connect with the private IP address directly. He or she must use public IP address to connect to a device A. But what if we only have a public only a public IP address? How we connect with the device A? Okay, in this scenario, we need to use the router's NAT function. The NAT means network address translation. NAT acts as an interface between the private network and the public network, which is available between the internet and the local area network when a request is sent from the private network to the public network. When a device in the local area network with a private IP address, and if this device needs to communicate with the outside network, it will use the public IP address in the network gateway to identify itself to the internet. And this translation of converting a private IP address to public is done by NAT. For example, a computer in an internal address 192.168.1.10 wants to communicate with the web server somewhere in the internet. NAT will translate the address 192.168.1.10 to the company's public address. For example, the public IP address is 20.20.20. So the internal address is identified as the public address when communicating with the outside world. In this scenario, we have two NUO NVR in local area network and with private IP address 192.168.1.10 and 192.168.1.30. And both NUO NVR are using the 80 port for the web service. So how can the remote site user connect with both NUO and NVR by only a public IP address? We can use the router's port forwarding function to allow the remote user to decide which NUO NVR he or she wants to be connected with it. For example, we can set up a 192.168.1.10 this NUO NVR A. Internal web port is 80, and the external web port for this NUO NVR is 8080. So if the remote user wants to access the NUO NVR A web page, he may input the public IP address 20.20.20.20 with the port 8080. And if the customer wants to access the NUO NVR B web page, this user needs to set up 192.168.1.30. And the NUO NVR B internal web port is 80, and the external web port is 8090. So if a remote user wants to access to the NUO NVR B web page, the public IP address will be 20.20.20.20 with the port 8090. So how to set up the port forwarding on your router? First, log into your router web page. After that, what we have to do is to find the public IP address of your router and set the port forwarding on the router to NVR LAN IP address. You can see the public IP address of your router in its configuration or status page. And then go to the port forwarding or virtual server page to set up the port forwarding function. For this example, I use the virtual server and key in the name, the private IP address, and set up public port and the private port. For example, the NVRme2 private IP address is set up 192.168.1.10, and the public port is 8000, and the private web port is 80. So you can also configure port forwarding live streaming port 5150 to public port 8010. And the playback port 5160 to public port 8020 in the router setting. And after the setup is complete, the remote user can connect with this NVRme2 web page and key in the public IP address with the 8000 port and receive the live streaming and the playback by port 8010 and 8020. Okay, the last topic we will let you know which port you need to set up port forwarding in router if you want to see the live view playback via web. In this page, you can see there has 3 NUO NVR with a different private IP address. And if a remote user wants to use a remote live viewer and playback or iViewer or new client to see NUO NVR live view and playback via internet, which port does user must to be open? Okay, for the main console and the NVRme2 and the NVR Solo. If a remote user wants to use the remote live viewer to connect with the main console, Mini2, and the Solo to see a live view, the user must set up port forwarding 5150 in the router. If a remote user wants to use NUO playback system, connect with the main console, and the Mini2 and the Solo to see the recorded videos, the user must set up port forwarding 5160 port in the router. If the remote user uses iViewer apps, and all iViewer apps support both live view and one-channel playback, so the user must set up port forwarding 5150 and the playback port 5160 in the router. And the Titan NVR, both the live view and the playback port is the same. We call that the streaming port. So if a remote user wants to use the new client or iViewer apps to connect with the Titan NVR to see the live view and the playback, the user only needs to set up the port forwarding 5250. Finally, this page shows the NUO NVR port forward information. You may refer to this table to open port for your NUO NVRs. Okay, we will take 5 minutes break, and if you have any questions, please input the question panel.